In thermal and combined cycle power stations, water is far more than just a working fluid. It is the lifeblood of high pressure boilers, heat recovery steam generators, and steam turbines. Even tiny amounts of dissolved minerals, silica, or suspended solids can create serious damage over time. Scale on boiler tubes reduces heat transfer, raises metal temperature, and can lead to tube failure. Carryover of contaminants into the steam path can also attack turbine blades and control valves. That is why high purity makeup water is not optional, it is a reliability requirement. Reverse osmosis, or RO, is one of the most important barriers in that water treatment chain. Today, we are taking an inside look at how an RO plant operates, which critical parameters engineers and operators must monitor, and how to troubleshoot the most common operational challenges before they become forced outages. Before water ever touches an RO membrane, it must pass through effective pretreatment. In most power station systems, this starts with multimedia filters that remove larger suspended particles, followed by 5-micron cartridge filters that catch fine solids before they reach the membrane elements. This step is essential because RO membranes are highly effective but also sensitive to fouling and plugging. From there, high-pressure pumps push the feed water into spiral wound pressure vessels. For many brackish water RO systems, operating pressure is typically in the range of 15 to 30 bar, depending on feed quality, temperature, and required recovery. Under natural osmosis, water tends to move toward the side with higher salt concentration. RO reverses that process by applying pressure greater than the natural osmotic pressure. Pure water molecules pass through the semi-permeable polyamide membrane and become permeate, while dissolved salts, silica, hardness minerals, and other contaminants are rejected and carried away in the concentrate stream. In a well-operated plant, that separation is continuous, controlled, and closely monitored. To keep an RO plant efficient and prevent premature membrane failure, operators should continuously monitor the condition of both the feed water and the membrane train. First, watch silt density index and turbidity. As a practical target, SDI should remain below 3 to reduce particulate fouling risk. If SDI begins rising, the problem is usually upstream in clarification, media filtration, cartridge filters, or chemical dosing. Second, monitor oxidation reduction potential and pH. Free chlorine can permanently damage polyamide membranes, so ORP confirms that dechlorination is effective before the water reaches the RO. Third, track differential pressure across each stage. A rising delta P is one of the clearest early warnings of fouling, scaling, or blocked feed spacers. Fourth, monitor permeate conductivity. If conductivity increases unexpectedly, salt rejection may be falling, a membrane may be damaged, or an O-ring may be leaking. Finally, control recovery ratio. Higher recovery improves water yield, but if it is pushed too far, minerals can exceed their solubility limits and crystallize on the membrane surface. Good RO operation is really about keeping these numbers stable, trending them daily, and acting before alarms become failures. Even with good pretreatment, RO plants face 3 major operational challenges during daily service. The first is scaling. This happens when minerals such as calcium carbonate, calcium sulfate, or silica exceed solubility limits and form hard deposits on the membrane surface. Correct antiscalant dosing, proper pH control, and realistic recovery settings are vital. The second challenge is biofouling. Microbial growth can form slime layers inside membrane elements, increasing differential pressure and reducing permeate flow. Maintaining clean pretreatment, controlling nutrients, and applying approved biocide practices where suitable help keep this under control. The third challenge is chemical degradation. Exposure to oxidizing agents, especially free chlorine, can attack the polyamide layer. Once that membrane chemistry is damaged, cleaning will not restore full rejection, and replacement is usually required. When normalized permeate flow drops by about 10 to 15% or differential pressure rises beyond normal limits, it is time to plan a clean in place. A targeted acid wash can remove mineral scale, while alkaline cleaning can help remove organic and biological fouling. The key is to clean early, clean with the right chemistry, and confirm recovery with post-CIP performance data. Mastering RO operation is not only about producing clean water, it is about protecting boilers, turbines, condensate systems, and the long-term reliability of the entire power station. When pretreatment is stable, SDI is controlled, oxidants are removed, differential pressure is stranded, and recovery is kept within design limits, the RO plant can deliver consistent high purity water while extending membrane life. If you found this technical breakdown helpful, please like, share, and subscribe for more power plant operation and maintenance tutorials. Brought to you by Nawaz Ali Lakho, a power industry pro for learning and knowledge sharing.